Welcome to our maths class. Today we are going to study subsets. Let us understand the concept by considering an example. Set A is set 1, 2 and 3. Set B is set 1, 2, 3, 4 and 5. Now look at all the elements in set A, that is 1, 2 and 3 are there in B. In such case, we can write set A is a subset of set B. So, when a set A is a subset of set B, if all the elements of set A are there in set B. So, now we can define a subset. What is a subset? A set A is said to be a subset of set B if every element in A is also an element of B. So, in this case you can see every element of A are there in set B also. Then we can say set A is a subset of set B. In maths, we usually write A is a subset of B like this. So, we can see instead of writing the whole phrase of is a subset of, we use just this symbol. So, this symbol is used to represent the phrase is a subset of. Also, instead of saying is a subset of, we can also say is contained in. So, we can read this as A is a subset of B or A is contained in B. The meaning is same. We know if A is contained in B, that is simple terms, all the elements of A are there in set B. If A is a subset of B, we call it is the same meaning. That is, all the elements of set A is also an element of set B. Let us say it in another words. For that, let A is an element of set A. We know epsilon is used to represent the phrase is belongs to or is an element of. That we already studied in previous section. Also, if A is an element of B, then we can say A is a subset of B. So, when we can say A is a subset of B, whenever A is an element of A, then A is also an element of B. So, we can write like this, A is a subset of B if A is an element of A implies that A is also an element of B. It is just a simple terms. If A is a subset of B, then every element in set A are there in set B. This symbol is used to denote the phrase is a subset of. So, this symbol, that is a cross over this symbol, is used to denote the phrase is not a subset of. If we are writing A is a subset of B like this, then we can write D is not a subset of E like this. So, here we studied what is a subset and how to write it. So, what is a subset? If A is said to be a subset of set B, if every element in A is also an element of B. Let us look into some more things we need to understand in this case. First thing, every set is a subset of itself. That is, A is a subset of A. Why? It is very simple because all the elements of set A are there in set A. There is no doubt about it. If I write set A like this, what are the elements? 1, 2. If I set A again, then it is again 1, 2. So, all the elements in set A are there in set A itself. So, we can say every set is a subset of itself. The second point, a null set or an empty set is a subset of every set. because an empty set is not having any element. So that becomes a subset of every set. Phi is used to denote the null set or an empty set. We know another denotation for an empty set is like this. The third point, that is A is a subset of B and B is a subset of A if and only if A is equal to B. Why? Because if A is a subset of B, then every element in A must be there in B. And if B is a subset of A, then every element in B must be there in A. And this can happen only if A is equal to B. You can see one example here. If A is equal to 1, 2 and B is equal to 1, 2, 3. Now look at every element of A is there in B. So A is a subset of B. But B is not a subset of A here because every element of B is not there in A. So this condition is wrong. So A is not equal to B also. And if B is having only elements 1 and 2, then we can see A is a subset of B and B is a subset of A. Because every element in A is there in B and every element of B are there in A. And you can also see A is equal to B. So what we say? A is a subset of B and B is a subset of A if and only if A is equal to B. That is, it is possible only when A is equal to B. And look at this, we use a denotation like this. It is a double implication. That is, if A is equal to B, then A is a subset of B and B is a subset of A. And if A is a subset of B and B is a subset of A, then A is equal to B. It is a double implication and we usually read as if and only if. It is briefly written as if. So we studied the third point here. Now the fourth point. If A is a subset of B and A not equal to B, then we can call A is a proper subset of B and B is a superset of A. So when we can call B is a superset of A, if A is a subset of B and A is not equal to B. We can say a simple example here. Let A is set 1, 2 and B is set 1, 2 and 3. You can easily say A is a subset of B and A is not equal to B. So in this case we can say A is a proper subset of B and B is a superset of A. Can you say another example? You can easily say set of mangoes is a proper subset of set of fruits. And set of fruits is a superset of set of mangoes. Now we are going to study relation among common sets in mathematics. We already studied about these common sets and their mathematical notations in our previous video. If you are not familiar with that, please watch that video. The common sets there we studied are integers, natural number, rational number, irrational number and real number. What is an integer? We know it is minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3 and extend up to infinity. And what is a natural number? It is 1, 2, 3 and it will extend up to infinity. What is a rational number? Q is equal to set of all x such that x is equal to p by q. P, q are elements of z and q not equal to 0. What is an irrational number? A number that is not rational or irrational numbers. So we can write set of all x such that x is an element of R and x is not an element of Q. And what is a real number? it is rational number plus irrational number, that is q plus t. Now, can you reduce a relation between these common sets in terms of subsets? It is very easy now because you can easily see all elements of n are there in Z. Therefore, n is a subset of Z. We also know all integers are rational numbers. So, it is very easy to write Z is a subset of Q. And from this relation, it is very easy that Q is a subset of R, T is a subset of R. Now look at, is N is a subset of T? No, because if it is a natural number, surely it will come in the rational number. So, elements in natural numbers are not there in irrational number. So, N is not a subset of T. In this way, you can make relation in terms of subset for common sets. So, I think you understood what is subsets. In next video, we will come with a new topic. Study notes and other materials for our videos are available in our website youtube elearning.com. So, stay tuned with us. Keep learning.